Okay, so our presentation this evening is going to be from Paul with SAKE Robotics, and he's going to talk about their line of rippers.
Hi, can you guys hear me all right? Does this work? That work?
Yeah, as soon as everybody gets set.
Hi, I'm Paul Ekas. You know Gertz. Gertz and I do this stuff, so we're the main people who create this product. So SAKE Robotics, SAKE Robotics, don't care. It's my last name backwards. We make rippers for doing useful work. So I had a belief a number of years ago that robots would start to do stuff in the environment that we live in. I jumped in, started making rippers for that, and you're going to see a little bit of the history of that. But right now, where we are with machine learning and rippers is, this is a little bit old. Warehouse and shipping automation is done, food services being done, hospitals being done, grocery stores, I think we're on the edge of being able to do that. Decluttering is being done, dishes, right, TRI just had a video off doing that. Laundry, I'll show you one that's robots doing a little of that, but they're doing more today. So all this stuff is turning on because of machine learning, and the objective is to have a gripper in the market that actually addresses the rest of that type of operation, being able to work in our environment for a cost structure that makes sense in our environment. So the vision is to deliver the lowest cost, high dexterity robotic hands that enable next generation high value robots. So we have what's called the Easy Gripper. It does reliable grasping across size and weight. It's lightweight. I mean, it's under 400 grams. So it's really lightweight, but it can hold 5 kilograms. It's very durable, it's human safe, it's easy to use, and works on many robots. So I'm going to just show you a variety of grippers. This is accelerated. I'm not doing any demos here, but you can see here it's picking up a variety of things. And this is, the context of this is, again, where we started off was, how do you do stuff in our environment? So it looks like this, and it actually starts moving towards things that robots are being used in now, if you look at some of the different videos that we'll put up here. So being able to pick up an empty paper cup, fill it with water, and pick it up again is actually a very useful thing. It's not easy to do. You have to have good sensitivity on the robot to be able to do that. We do it for a variety of things. I'm going to skip that one. Here it is on a UR3, right? This is, excuse me. This is kind of a mainstream use of rippers, which is just moving stuff around. And so URs are quite popular for that, and not much there. This one I think is one of the most interesting. So this is out of Japan, and Waseda University, and they have 2 robot arms here, and vision, and 2 grippers. And they teach it how to fold something. And then what happens is they're actually, so if you are experienced with machine learning, you might have a 7-layer network to recognize something. What they've done is put 7 of those networks sequentially that represent time. And they estimate 7 steps forward and do a step. Estimate 7 steps forward and do a step. And they don't use inverse kinematics to drive the motors. It's all neural network driven with predictive information, and anytime they put something up, it can fold it. And they'll do it with books, they'll do it with towels and stuff. So this is actually pretty cool. That's fairly old now, but that's the kind of stuff.
Whose robot is that?
You know, I just met the guy. He was here. I just met him. I'm terrible with names, I apologize for that. But Japan, this company makes a fair number of these.
So is it a stepper motor, so the output is just step plus?
No, all of this is, harmonic drive motor robots. All right. So standard robot arms, no fanciness in it, no torque control or anything particularly. Simple, and then they're driving it with the network on it. So cool stuff. Lots of papers on this. Here is another one that's just out of Israel, and I'll go a little farther in it. And they're actually doing this assembly. So this was a KUKA challenge for assembling parts, and so Ben Gurion University in Israel did it, and Yuval was the student on this, who I had the opportunity to meet in Montreal recently. So that was a KUKA challenge. that was implemented by somebody using the gripper on a KUKA robot. So we have software that drives these that all comes from Gertz, so it's good. Python on Linux, which is the majority of the stuff that I apply. Python and ROS. C# and Windows, which actually has gone into Japan because people are building equipment around that and have the UI on it. And then Universal Robots with Python, but also with the GUI, so it can be used in that. So the key thing on the grippers is they've gone through a lot of development. I'll go through that, but right now where they are is we've got, I'll just start from the top. The technology is based on tendon-driven grippers. The challenge in tendons is they break because they wear. And so we developed technology where we run the tendons through super hard, smooth ceramic eyelets or over double row deep groove concave bearings onto a super strong winch. And what we've done we've got springs in there, so it wants to pull back and you pull it forward with the motor. Only a single motor, so very easy to operate. And right now we can run that, I have an example back here, it's run over 3 million cycles, full force cycles. It's on its 3rd servo. The tendons are actually in pretty darn good shape. And that was not easy to accomplish, and I'll go back into that. But extremely durable. You can see we have these pins on here. There's 7 identical pins. There's actually 9 with the finger pads on there. This is designed to be super easy to assemble and build and be reliable and low cost. So the goal is these things can be completely commoditized. We've updated it in the last 6 months, not the previous slide, but we have these replaceable fingers. The value of the replaceable fingers has come from sensors. So because these grippers are working in an unstructured environment, there's a lot of research around that. People are doing the very fancy hands, right? You see that. That's not going to come into our environment for a long time because a $100,000 hand is not really useful for doing most stuff that we need to pick stuff up and move it around. So our grippers have been very good for that. So we're actually getting a fair number of sensors on there. The first one, Zila Robotics, that was a sensor developed in Japan. It won ICRA 2017 Best Paper for robotic sensor technology. And they have got that commercialized now. And so I have one of the sensors here. I can't demo it here, but I have a video of it, and I'll show what that's doing. We also have gel sight going on at MIT with Professor Adelson. So that's an amazing technology if you haven't seen that.
So this fingertip has a sensor in it.
Well, yeah, when you replace our fingertip with one of these, you've got a world-class sensor. And the Zila robotic sensor, about yay thick, you can hit it with a hammer. It has 24 points on ours, and each one of those points can sense force and shear. And shear is the thing that's unique in there because we've got lots of force sensors, but when you pick something up, the way you don't drop it and don't over squeeze it is you pick it up enough so that you stop having slippage. We do that automatically. Robots can do that also, but they have to have the sensors for it. That's a sensor that does that.
You say sensor, but I don't see how is that communicating to the processor or whatever.
I'll bring that back and I'll show you.
All right.
But the key is people are putting sensors on these grippers, on the ends, from leading edge institutions because where we are right now working in machine learning for picking up objects in unstructured environments. In fact, Zila came out of the university that was doing that robot folding. They're really good at that kind of stuff. So here's the sensor view. So what you've got on the left side is a picture of these 24 dots. Each of those dots is a sensor, and when it's on the left finger from the gripper side. It's on that one. And they don't put it on both sides. They only put it on one side for some reason. You could sell twice as many if you put them on both, it seems to me. And so they're just running through there. You can touch these, you can move them, you can shear them, they're pretty cool. I'm going to skip that. And I'm going to go to this. And I'll run this multiple times because what you're seeing here is I've got a little tiny plastic empty container, and I'm about to drop a big heavy weight into it. Right, that's what you get out of shear detection. Right, that's how we touch the world. And so what you can see is they actually have a little controller on the side that goes down around and goes into the computer, just like everything else, right? And the thing I liked about that demo earlier of the little tiny Roomba things is they wanted to keep putting more stuff in. If you've seen our robot, it's already overflowing with cables and it's this big, so packing electronics everywhere is not easy. So that's pretty cool. These are all 3D printed. They're designed for injection molding, but they are 3D printed. And so everybody, I have had lots of people ask me over time, so it's open source and I get it, and it's like, no. It's designed to be a business. And so we've been patenting aspects around it. And so we've been doing that with the intent that we can have a licensing business, because if you don't own the core technology, you can't license it to anybody. So we have licenses or patents granted in the United States, Japan, South Korea, and we still have them pending in Germany and China, and others pending as well. So that's been a long, basically setting that up so that the business is viable and protected. So what we can do with it is all the parts can be injection molded, and they are designed for assembly, and we've been working on that over time, and I can show you how bad that could have been and how good it is today. And then they're just durable, lightweight, and easy to use. So that's actually the pitch for the product. And so when we're doing this at a trade show, which is where we're doing our advertising now, because we don't have the product in a high volume state yet, we're primarily just doing a minute or two demo, picking stuff up, big bottle of water, credit card, etc. So almost never do slides. But there's a little timeline here I'm going to go through. So in 2004, this is all supposed to be hidden, sorry about that. 2004, we did a prototype link, about that big. And so I had the pleasure of working early on in this, jumped into the SVROS team doing the NASA challenge. And so a fair number of people involved in that. And in the beginning, I just had a little tiny couple of fingers and said, I'm going to be building rippers. And in that process, I actually had an opportunity to meet Mike Ferguson, and he is one of the first people to see this, and was really positively reviewed, which is just stunning to me because that doesn't look like much. And so I kept developing, and that was the first gripper that we developed. And I had a servo on there, and I used to go to the SVROS users group, and I'd demo it, and this was the first one, and it crushed itself. Because I always like to do stuff in front of them that would push the limits. So we made two of these. That was the next generation. And I contacted Mike again. I took it down, and just as they were opening fetch, so Mike just happened to be here for the story, and I got to have a seat with Melanie, Mike, Eric, and Derek, and pitch this to them. And they asked me a question: how many cycles will it run out? I have no idea. Right? I can't even program this thing. I kind of have it working. I can demo for you this thing by peeking and poking the servos. And so they took one and they started running it, and it got 7,000 cycles. And I was stunned. That was amazing. And later I asked Melanie, so how many do you need? She said 10 million cycles. Okay, long way off from the dream. Right, so right there, I think one of these still lives in fetch, so that's kind of funny. All right, so right in the beginning in 2014, just brainstorming stuff to do, right? So that was one of the two vectors, or one of the vectors. That was another vector. Right, pretty interesting. Just I had no idea what the market wanted. I put stuff out there and playing with it, and so the first one that we built was this 3-finger one right here.
So were you involved with the industrial robotics market at this point, or?
I came out of semiconductors. I had no idea except almost 30 years ago, I got a patent on an integrated neuron with China Light Naval Weapons Center. 10-ish years ago, I was at Altera leading their product planning, and we were putting thousands of multipliers on. I was at 28 nanometers. I knew 22, 14, and 7 nanometers were coming, and I said, convolutional neural networks were turned on. This is going to happen. And stunningly, it did. And I just got lucky. I saw that, I believed in it, I lost my mind, and I started doing this. So I really had no idea going in. So I've learned everything since, and may not know anything now, but I have an opinion. So here, this is actually in December of 2014. And this is the first time I'd ever started picking stuff up with it. I ran this demo. I'm peeking and poking into the Dynamixel to control it. So I got the algorithm to control it. I just can't write the software layers above that. And we're working at this time with the NASA Robot Challenge, and the person who's writing all the stuff that's making the robot work is Gertz. So I start working with Gertz. But this is right at the beginning, and built the gripper that actually worked. But you can see it's very manual to operate. It was not easy to do this demo. And you'll even recognize all the objects, right? And by the way, I'd like to get that block back because it was nicely made and I made that block. So. I like making stuff. All right, so that was the first one, but the 3 fingers actually didn't work very well. There are a lot of 3-finger grippers out there, and I don't particularly like them because picking stuff up, that kind of shoots them around. And so I went to a 4-finger gripper, and this is in 2015, and showed it could pick up all kinds of different things. So I wanted to introduce this to the market. And they had ICRA in Seattle. I'm from Seattle, and I could pull it all together and have something that worked. And so I sent off an email to Robotics, because I use their service. And I said, you guys just introduced a new robot arm. I've got this gripper, which would really help your robot arm. Can I send it to you and you can put it in your demo? And they sent back. And they said, that's a great idea. We're sending you a robot arm. I was like, oh shit, I don't know how to do any of this stuff. So I literally went in and learned how to do the motion planning and everything else. I actually had to hire the guy that worked as a summer student at Fetch who wrote the Dynamixel ARM drivers. He's a sophomore at MIT. Ran circles in C++ around people. He came into my house for a couple of days, worked for me. We got something rigged up and worked, and then he went to summer at Google doing his stuff with some hypercube computing thing. So he was just awesome and got me to the next little step, which is I went to ICRA where they had the first Amazon picking challenge. And so the way that we'd show this is I wanted people, the challenge with the gripper is a gripper on a robot arm, you really can't tell what the gripper can do, and I'm trying to sell to people who would buy grippers. So I wanted something they could hold in their hand and pick stuff up and go, this is what it's like. So this is Chet, see if I can, Chet Jenkins, yeah, thank you. He's now a professor at Michigan, but
Was it broke?
is he broke? All right, so. No. So just nice guy. That's a drill handle. So the drill handle had a battery. I wanted a battery that I could have so I could run the grippers at the trade show. So there's a beagle bone black and a battery put on the bottom of this thing. The whole trigger had to rip it apart because the triggers are not designed to do what I'm doing. I turned it into an actual on-off switch, and then I could give it to people. And what would happen is that you go through that, and at the end of the day, when the most important person came, the battery would be dead. So migrated away from having the battery, but the whole technique, it really drew people in and engaged them. This is a cycle later. These are later generation ones. These actually have fingers that come off, and they're back there. and I'd met the team from KUKA's research labs, and they wanted to take that back. So they took a couple of those back for a coding event at KUKA where they were doing stuff. And so what you can't see is a guy sitting here like this with that Intel or the Connect up there, and he's trying to control these arms to pick stuff up by doing motion like this. So that was kind of cool. Well, the challenge on these other ones is you just needed a whole lot of strength, because the servo pull on this has about 200 newtons of pull force, and we run it at half, 200 newton meters of pull force, we run it at half centimeter diameter. So it has about 1,200 newtons of pull force. So it really needs a stiff structure around it to handle the tendons moving through the system. So we came up with this system of 2 parallel metal plates, and that was what was called the Gen1 Rippers, right? Despite all the generations before that, these are the ones that came out, and these are Gen1 Rippers. And we made it work on a fetch. That's an Obu, that's in China. This one's interesting. Anybody recognize this one?
Universal robot?
Hmm?
Is that UR, Universal robot?
This is from Kindred's website. So when these came out, I got them into Kindred, and they immediately deployed them. They were playing with all kinds of stuff, and these came in. All of a sudden, they were successfully picking. So they were my first deployment, and then they designed me out, kind of copied it, and then went it up. And they actually have a nice gripper for what they were doing. But that was really good to get that piece of feedback around a team that's doing a lot of AI and liked the grippers, right? Any positive feedback's like, oh, there's something valuable here. And so they really went over and they had lots of visibility of different things. So that was pretty fun. And here's another one. This is from their public website. Both of these were from the public information that you used to have up. So you can see the bottom one. That was that Gen 1. Came up with the, how do you really cost reduce this, right? There was a lot of stuff on there that was mechanically built so that you could experiment and take it forward and build a variety of things. But needed to make it a much smaller, prettier module. And so that's what the top one was. And went to the World Robotic Conference in China, in Beijing. And it was a conference of all China. It wasn't a world conference. It was pretty interesting. But they had so many robots there you can't believe. And one of the guys there liked what we had and wanted a gripper that would do massage on fat for the Chinese market. Right? So he saw that top one. He said, that's the way I want to do it. So I worked. So I actually had a customer with a pretty big opportunity, went after that, and and this one's good. So I sent them to them. They couldn't pay me because it's RMB. Government couldn't let them do anything in dollars, so the whole thing fell through. But I've done a lot of development on it, and I've got a second one of those there that are blue that was actually a production version. Learned a ton bringing that online.